So welcome to our very first online lecture, Descriptive Statistics. So here I've opened up in Excel a data set called Adidas sales. There are 3 columns: region, year 2000, 2009. And there are 4 rows of data, right? Europe, North America, Asia, and Latin America. When you take a second to look at this data and think about what are some stories that this data is telling us. Every data is trying to tell a story, or you can extract stories from a data. That's what we do in statistics, right? It's helping you answer a burning question you have, or just a question, some curiosity about the population you want to know. So here, take a second, you could potentially pause this lecture and ask yourself, okay, what is the story it's telling me? I'm really hoping that most of you did stop for a second to think. Stop the lecture, ask yourself, what story is it telling me? And you may have come up with, okay, between 2000 and 2009, it seems like sales grew. Nobody went down, everybody went up. Or who has the highest, who has the lowest sales in whichever year, right? It seems like Latin America, even though it grew from 2000 to 2009 in terms of sales, it still stayed the lowest, right, of all the 4 regions that we are stratifying by. And other questions you might have, that the highest in Europe, but maybe the growth wasn't as much as compared to the growth of Latin America. So this is an example of what we do with data. Now this is a very clean, straightforward data, and yet you can come up with so many different stories about it. So that was your first look at raw data, right? We had raw data on Adidas, and if you look on Canvas, I always post data under files on Canvas. So if you look under files, Canvas, that's where I upload the data. So you can pull up the data, I think I call it CEO gender. So pull that up on your computer, or you can simply look at it because I'm going to pull up for you here. So here is CEO data underscore gender in Excel. 3 columns, you have 3 variables: age, salary, and gender, and there are a whole bunch of rows. So this is your sample size. You see, if you scroll all the way to the end where the data finishes, this is at 61. So you know that you have a sample size of 60. Those are the few things that you look for anytime you work with raw data. What variables are you working with? What type of variables are these? How many samples do I have in my data? Critical questions to start. Should become very natural once you start working with data frequently. So look for those things and you say, okay, gender is coded as 1 and 0, age, salary. So there we have it. We looked at 2 raw data. So variable you saw in both of the data sets. The first one with Adidas, there were 2 variables, right? Region and year. The second one, CEO data, we had age, salary, and gender. So first things first, that data set, those 2 raw data we looked at. So here I'm populating your notes. So if you are reading this, I've told students that you can either print this out and participate by writing as you watch a lecture, or you can simply type it on your whatever device you're using. So pick one that works well for you. It's different for everybody. There's no right answer. Going back to the lecture, so 2 raw data. We saw Adidas sales and CEO. Those are sample data. It means that 60 CEO was extracted from a larger population of all possible CEOs. And that, when I say all possible CEOs, say in the US, that would give you population data, right? So you have your sample, you have your population. You only usually work with sample data because it's more manageable, right? Do you want to work with a sample of 60 CEOs, or would you rather work with 600 million, right? That's going to be very time consuming, but very accurate. But in the real world, realistically, it would be difficult to work with such a big data. You're going to have to need super speedy computers. Excel probably won't even be able to handle it. So you're taking this class because we want to be able to work with a sample and say that sample will yield results that are representative of the population. That's representative if you were to sample every single CEOs in the country. So we have your sample versus population, two different types of data. Anything, any math or any computation from the sample would become a statistic. That means if you compute the average sales for 2000, that average is a statistic because you got that number from your sample data right here. So that is your sample data. Let me highlight that for you, sample data. Whereas if you calculated anything from a population data, that will give you a parameter. So parameter is from a population data, whereas the statistic is from the sample data. They're really different. You need to know the difference because this is the foundation of statistics. Get the jargon cleared up, memorized if you need to, before you can build anything on top of it. A quick mnemonic I like to share with my students is that sample data here. Do you see how it's S? Anything you calculate from a sample will give you an S statistic. Whereas anything you calculate from a population P will give you a parameter. So that will help you memorize, remember, learn it. We're just going to focus on the CEO data for now. There are three variables we saw, right? Gender, salary, age. Not in that order, but there are three variables. Let's identify what type of variables we're working with. So let me open up that data so you can see what I mean. So here's your data again. Age, then my question is, can you compute the average of age here? Yes or no? Right, so if you don't want to fall asleep, it's very helpful for you anytime you're watching online videos or lectures to answer these questions like I'm teaching you one-on-one. Could you compute the average age? Of course you can. I could do it in Excel right there for you. Same thing for salary. Compute the mean, the average. Can you compute the average for gender of 0 and 1? No, right? You can, but it wouldn't make any sense. It would be garbage. Calculating an average for 0 and 1, or I used male for female, M and F, it wouldn't make any sense, correct? So we need to be able to, once you know you have variables, you have a sample size of 60, then you need to know what type of variables you're working with. So here's salary, as you saw, you can compute the average, is a quantitative variable. Same thing for age, so you can write quantitative in that space. Gender, on the other hand, is a categorical variable. It's a categorical variable because it has how many categories? Two categories, males and females, right? Can you think of examples where there are other type of categorical variables you might have to work with? Region, right? Like in the data sales, America, North America, Asia, or education status, high school, college, grad school, master's, PhD. So those are examples of categorical variables. Then here now we have a thought question for you. What if you're not interested in the average age? What if you wanted to stratify by age? And you can say, hold up, what does stratify mean? Right? So like in the data sales, stratify, you're looking at different regions. So when you stratify by region, you're splitting up into different regions and comparing, say, Latin America to Europe. So if you wanted to stratify by age, then you want to convert age into from a quantitative variable into a categorical variable, right? So you can stop here and think, how do I do that? How would you do it? How would you convert age, which is considered a quantitative numerical variable, into a categorical variable? Maybe there's a question you want to ask in terms of the CEO data. You don't care about the average age, but you want to know if you're above 50, do you make more money than those below 50? right? Then you can stratify into two levels, two categories, above 50 and below 50, or however many categories you want. Does that make sense? You can do the same thing for salary, those making over 100 versus below. There's a story you want to say about that. There's a hypothesis there sitting waiting for you to answer. So whether you convert it from a quantitative to a category variable or not, that depends on you. Depends on the question you want to ask. Depends on the story you want to tell. So a little bit more populating your notes here, then you probably know the answer of the first one, right? The categorical variable as groups. The second one is quantitative variable, takes on numerical variables. And then I want you to scroll down here, stop this lecture now, practice it. It says try it for a reason because I want you to try it. Try it, these 5, and then come on back and see if you have them correct. So age is, it says in brackets year, so it's going to be a quantitative variable. Classroom seat location, front, middle, back, those are categories, so it's a categorical variable. Number of songs on your phone is quantitative, you can even say numerical. Time spent studying, in brackets, is hours, so we're going to say this is a quantitative variable. And the last one, soft drink size, small, medium, large, super size, that's categorical variable. So be able to distinguish when you see any variables you're working with. Know right away, is it numerical? Is it quantitative? Is it categorical? And notice that I said numerical and quantitative together, they're interchangeable. But the most common way is probably going to be quantitative. But if you say numerical, fine. So that's something you have to be able to know, just differentiate between the two. Key component of basic statistical work. So we have our CEO data that you see here, right? This is only a sample size of 60. But what if you had a sample size of 6,000? So you're scrolling from the first row to 6,001. It can be very mind-numbing and really hard on your eyes. If you want to tell a story, you want to explain what data you have with someone, you want to maybe present it visually, you want to summarize your data somehow. So the first part here, we're going to look at how to do that for categorical variables. You can have a numerical summary for categorical variables. So going back to CEO data, you've got males and females. This is an example of a frequency table where you're counting and then computing percents. Because if you tell someone, oh, in my data, I have 2 males, versus telling someone I have 80% male or 20% male, that is much more meaningful than to give someone a raw count when you have categorical variables. So let's see, if you look at your data and you counted it, you'll find that there are 50 males and they are 10, which you know the sample size is 60. So here that math makes sense. Always check. Use this frequency table to help you make sure your data makes sense, because trust me, sometimes it doesn't. Some things go missing and doesn't add up to 60. So you might have to do a little investigation to see that your data is workable before you spend hours and hours analyzing it. The percent, this would be 50 over 60, will give you about 83%. 10 over 60 would give you about, if you round it up, 17%, right? Make sure that percentage adds up to what? So here you have your frequency table. This is one of the very first things I do after I check my sample size, type of variables I'm working with, and I know I have categorical variables. I make a frequency table because I want to check that my data makes sense. I want to know what I'm working with. So here in the CEO data, I'm thinking, okay, I have 83% males and only 17% female. Should I be concerned? Is this data legit? Can I use this knowing that they're 83% males? Is this representative of the population? So these are questions that I'm teaching you, giving you tools that you should think about to use because you have a course project by the end of the semester. You're going to be given a raw data of some kind and you're going to work and ask questions about it. So this is a Very common step. Look at your frequency table, check your data makes sense. So then if you say, well, okay, in the real world, there are certainly more males holding the CEO position than females. Then you can say, okay, let's continue with our analysis. So we have a frequency table, but you can also make this visual by making a bar graph here in Excel called CEO data gender. So here right away you see there are 50 counts, right? 50 males, 10 females, and that's very flexible in Excel. If you want to add a percentage, you can. If you want to change the color, go for it. Just make sure you have some kind of data dictionary. So here, my y-axis is not labeled clearly. You should probably say counter of some sort. So there is your visual summary of your data, just the gender, because it's categorical. That's the only categorical variable we have. You can do the same thing to communicate your data using a pie chart that you see here. Now, which of these two do you prefer to use and why? So think about it. So stop the lecture, think about which one do you like and why? Which one would you use professionally? Which one do you think sends the message stronger? Now, for some of you, you might like the bar graph better and you might like the pie chart better, right? But so if you're thinking you like the pie chart better, that's very normal. It's beautiful. Got two colors, you can see right away, regardless of percentage, that it is really interesting that there's a lot more of that blue stuff than the red. But think about if you have multiple categories, right? If you're not working with gender, you're working with, say, region. You have 4 or 5, 5 or 6. How would that look on a pie chart? It probably won't be as easy to send a message, to summarize your data if you have a pie chart with multiple categories. So then the bar graph would be great. But notice that that bar graph gives you that number really quick, right? On the left. And if you add a percentages, it'll probably be even clearer. So professionally, if in doubt, go with the bar graph. So now we're going to do the same thing. We're going to summarize your data, the CEO data, but now you're working with quantitative variables. So right here, that very first sentence, I say, the distribution of a quantitative variable tells us what values the variable takes on and how often it takes those values. So to you, what does distribution mean? Right, if you have a data of 60 CEOs, distribution is you throw out there, what does it look like if you're picking, say, salary or age? Where are most people located? Are they people super young or super old, making a lot of money and not making a lot? Where are most people? What's the average? You can tell that visually, not just by computing the average. We have a graph with some kind of visual summary. You can pick up those information immediately. So that's the beauty of making graphs, presenting visually what you have. We're going to do it differently when you have quantitative variables. We're going to make a histogram to show the distribution. So here that first one is, this is a histogram. Histograms show the distribution of a quantitative variable. I'm going to highlight this for you. I'm going to say it again. If I say something twice, you should probably highlight it on your own as well. Histograms show the distribution of a quantitative variable. Please, please do not make a histogram for me for categorical variables. And trust me, you can do that in Excel. You can do that in any kind of statistical package, but it would be complete garbage to me. It'd be nonsensical. Please don't do that. And I get that a lot. A lot. In the course project, at the end of the semester, makes me wonder if you really understand what a histogram is. So make sure you know that I only make histograms if you're working with a quantitative variable. So let's scroll down and take a look at what a histogram is. So you can look at it visually. This is a histogram. We're working with a new set of data now. Do you see how it kind of resembles the bar graph from earlier? Yeah, right? But it's different, and we'll talk about the difference in a little bit. But let's take a look at this raw data we have. We have a new set of data. looking at weights and pounds of students in some intro to stats course, right? You have all this data, and then it's split up into different classes under weight groups. So each one of this is a class. And that just simply means you're dividing it into different range. This right here, I'm pointing it with an arrow. This is a class. This is a class. So between 100 to right below 120, there are 7 students in this class. 120 right below 140, there are 12 students in this class. You can decide how many classes you want. It doesn't have to be so many like in this one. You could just have 3, 4, or 5. That's arbitrary. That's up to you. You need these things to make a histogram, because once you have the class, then you can make a histogram, because the bottom, your x-axis, is based on the class. So each of these bar represents one class. And the y-axis is the number of students. So it's counting, right? So you can look at the distribution of your data. So if you look at this graph here, notice that there's a space between, what is it, 240 and 260. There's a space right here. You see that? So this is what makes it different from a bar graph, besides that you're working with quantitative variables, is that this space, when you have a histogram, it tells you something. It tells you that there are 0 students in this class. So if you scroll up and look at the class data, do you see how there are 0 students? There are 0 students right here who falls between 240 right under 260. So your histogram, having that space, it tells you there's no one here, versus in a bar graph up here, that space is just cosmetic. It doesn't tell you anything more than what you need to know. So there's that for a histogram. More importantly, for histograms, if you're looking at this, what can you say about this weight data? All right, so stop your lecture here. What can you say about this data? So you might have said, okay, I see 2 peaks. Right here, 1 and 2. This seems like there are a lot of students in this class. So if you look up to confirm what you're seeing, then yes, you see there are 12 students in that first one here, 12 and 12. Right? Let's say you don't have this in front of you, then that graph, that histogram would tell you this information by itself, right? And then you're going to look down here again and say, what else did you say about this histogram? You know, we talked about the space here, right here. But what about this where it says 260? Is this all the way by itself? This 260 right here. Should you be concerned about this one? There's one student all the way out here. It's an extreme observation. Do you know the name of that? For an extreme observation is an outlier. So this is a potential outlier here. So you should be concerned. In your histogram, if you have an outlier, you want to take note of that and say, I am working with a data that has potential outliers. So I need to be very careful. I need to be cautious when I report my average, my mean. Average and mean, the same thing. You need to be careful reporting that average, because you have outliers that will impact the true center of your data. So if you have a histogram that tells you have outliers and you report the average, it's inaccurate. It's not useful information for anybody when you do that. If you don't have outliers, fine. Average will give me a great idea of where most people are, where the center of the data is. But when you do have extreme observations like this one, outlier, potential outlier, be really cautious with what you report. So when you have histograms, we're going to look for patterns. So now we have one histogram here. What's the shape of this histogram? What can you say about this shape? That it's perfectly symmetric, right? Do you see that? If you, at the very center, you fold it in half, it's a mirror image of each other. So this first one, we're going to call it symmetric. Or you can say perfectly symmetric. Perfect. that first one. No outliers in this first histogram. So if you compute the average, that's fine. It'll give you a pretty accurate representation of the center. What about this second histogram here? Do you see how if you were trying to trace to look at the shape of this, what would this look like? It would look something like this, right? And you can say there's something going on. There's a little tail to the right side. Potential outliers, red flag. So if you're looking for the pattern here, then you'd say, I think this is skewed, but which way? This is skewed. Let me write this out for you. This one is right skewed or positively skewed. And a way for you to remember that is where I just drew that diagram. This one here, you're going to trace it. There's that tail here, right? So this tail right here, that's why it's skewed to the right. Because you have extreme observations on the right side where it's positive. So this is positively skewed or right skewed. My professor from many, many years ago gave us a mnemonic for this, is to think of this as a whale. So I'm going to attempt to draw a whale here. So this is my whale. This is his teeth. And this is his tail right here on the right side. So that's a way, this tail right here. So look for the tail to help you remember what skewness it is. Positive, negative, right, or left. I love giving out questions on exam where I give you a histogram and ask you to describe the pattern. So moving on to the last one here, your histogram, then you should really stop here. Trace this out yourself, look for the tail, and figure out, is this positively skewed, is it negative, is it right or left? So if you're tracing this, something like this, for exaggeration, your tail is, where's your tail? Right here, right where the negative numbers are usually located on the left side. So here you want to be concerned about reporting averages or even standard deviations. So this one would be, hopefully you got it right, negatively skewed or left skewed. So that is your practice of how you approach describing your data. Hence this lecture. This whole section in statistics is called descriptive statistics. Your boss might come to you and say, here's your data, run some descriptive stats. And these are the kinds of things you would do. It's the kind of questions you might ask. Concerns about your data. Validate your data using basic signs like this.